All right, let's remind ourselves, what do we mean when we say index form? Josh.
Something to the power of.
Great. And what does a power look like when I write it with another number? Sharon.
It's a small number at the top right.
Okay, so Stuart, what would you put for the first one?
First question.
Yep.
7 squared.
Yep. 7 squared is the same as 7 to the power of 2. And remember, this small number here tells me how many times the large number, the base, appears when we're multiplying them together. All right. Any takers for the second one? Damon?
F cubed.
Where'd the F come from?
7.
7 cubed?
7F, same thing.
Okay. Don't worry too much about the brackets. Are you comfortable with me saying that this is the first one and this is the second one?
Yeah.
All right. How many 7s are there in total? 5. Okay. So this is 7 squared. This is 7 cubed. And you've just told me that this is 7 to the 5. We're going to develop a rule for this. You may already have seen this last year. All right. What about the fourth one? This one involves the letter M as the base. Yes. Now, do you want to explain how you got that, Matt? It's 5 M's. That's it. All right. Next one.
M squared.
M squared. Okay. And again, are you comfortable with me saying it's this one divided by this one?
Yeah.
Okay. So, hands up if you have seen this idea before, where if I have the same number on the top and the bottom, I can cancel in a fraction. Hands up very high and clear if you've met this idea before. Okay, so about half of you. Okay, so if you didn't know that, now you do. So just have a look on the right here. Can you see down here? In this fraction, I've got 3 in both the top and the bottom. So this would be 15 over 21. And what I'm saying is, because I can break it up like this, I can just cancel the 3 and get rid of it. Same thing here. I can also cancel a letter such as K. All right, so if I've canceled, it just turns into the number 1. So how many M's are left here now?
3.
There's 3 of them. Okay, so what you've just told me is M to the 5 divided by M to the 2 is M to the 3. Today, we're going to be able to do these calculations without having to write them in expanded form. Okay? So let's do some examples, and this may look very, very familiar from last year. If you want, you can write these down. If you're feeling a bit uncomfortable with indices, I would suggest you get all of this down in your workbook. Okay. So have a look in this first example on the top left. How many 7s are there going to be in total? Louis. 5. And what makes you say that? That's right. So it's actually this first example that we did here. I start off with 2 7s, then I multiply by another number with 3 7s. In total, I will get a number with 5 of them. Now, instead of doing this, I don't want to write this out. But you've told me that there's a total of 5 by adding the numbers 2 and the number 3 together. All right. I'm going to start picking on people now to see whether you're following. So, who's up first? All right, Reese. This number here has 10 5s And then I've got another 20 fives. How many fives are there going to be in total? 30. So the way I'm going to write this is like so. 10 plus 20 is just going to give me the total. And yes, it is indeed 30. Thank you, Reese. All right. Let's go with McKenna. What are your thoughts of this one?
3 to the power of 9.
3 to the power of 9. Okay. So I agree that it's 3 to the power of 9, but we need to be clear on how we get there. So what was your thought process?
Well, you just plus the 6 and 2, and then add on 1 because of the extra 3.
Okay, so if you've forgotten year 9s, if I just have a number by itself, it's the same as that number raised to a power of 1. So even though there's no power there, it's implied that it's 1. So this is actually 3 to the power of 1 here in the top right. And all McKenna has done is she's taken the numbers and added them together. All right, let's go with Mia. What do you reckon here?
87
Okay, and how did you get that?
plus the 5 and 2.
That's it. Notice that here, our base, the big number, is a letter rather than a number. Oh, did we have to do anything different?
No.
It's exactly the same because a letter can just represent any number. Okay. All right. So this is what we're going to call the first index law. Let's start with completing the sentence down the bottom here. When multiplying numbers with the same base, what should we do? Add the indices. Thank you, Louis. Okay, so that's the law in words. Let's now put the law into a formula here in the box. So Talia, do you have any ideas what we might put in this box?
Where?
In here. What should go where the squiggle is? Do you want to handball it to someone else?
Yeah.
Okay, choose the person. Phone a friend. Who's your friend?
Louis.
A to the power of n plus n.
Yeah. Okay, I've just taken the two indices and I've added them together. Is this looking familiar from last year? Okay. We're going over it again because we know you forget, and that's fine. You'll see it again next year. All right, so take a moment to get down the law if you think you need it. What I don't want you to do, year 9s, is to just memorize the formula without understanding where it came from. If I have 2 of them and 3 of them, then I have 5 in total. That's all this law is saying. Okay. All right, is anyone still writing? No. Okay. So we'll finish off with this page. Now, what I'll do is I'll change it to 5 and 2, just so that it's a bit clearer. So you don't need to write this down. The whole reason why we are introducing these laws is so that I don't have to do this with the expanded form every time. What's going to happen when I start cancelling? Let's do it.
The number's going to get smaller.
Okay. Shannon?
It's gonna start to take away each 4 at the front
Mm-hmm.
until there's nothing left.
On the bottom, yeah?
Yeah.
Okay. So how many do I have left now? That's 3. Can I obtain the number 3 using the indices
Yeah.
that are already available? Say that louder for the class, Matt. Use subtraction. Why are we subtracting though? Anyone can answer.
Because you're dividing, you're dividing the two numbers.
Mm-hmm.
And
So if I have 5 on top and 2 on the bottom, and I cancel 2, I'll have none left on the bottom, and I'll have 5 minus 2, which is 3 on the top. Okay, so now that we know this, we no longer need to do this cancellation anymore, and we can just subtract the indices. So, Mitch, what do you reckon we'll do here? Okay, Cheyenne? That's all right. Harry? It's okay. Talia? It is 7 to the power of 4. And how did you get 4? 12 minus 8. All right, let's quickly do the next two, and then we'll write the law, and then I'll let you get on with some work. Okay, so hands up if you think you know what this one is. Josh. This one. Yep. So guys, notice that I'm writing this line. I'm actually saying 12 minus 9. I would suggest, if you're doing a longer calculation, that you show this step. For a short calculation, it's fine to go here, straight to the answer, but you may find it useful to show that intermediate step first. And last one. Shannon?
8 to the power of 9. Sorry, 7.
Yep. And you did 18 minus 11. So if you wrote for me 18 minus 11 on your test, I would know that you understand this index law. But if you wrote a to the 9 with no working, then I wouldn't be sure that you knew what you were doing. Okay. All right, so we subtract the indices. And it's m minus n instead of m plus n. So if you multiply two numbers with the same base, you should add the indices. If you divide two numbers with the same base, you should subtract the indices.
So it's exactly the same as changing the operation.
That's right. Okay. So we're going to do a few more index laws over the next couple of weeks. But that's all for today. I'm going to let you get some work done now. So you can now start exercise 2B if you wish. We now have 3 teachers in the room, Mr. Steiner, Mr. Mawson, and myself. So there's no reason why you can't ask for help if you need it. All right, thanks everyone.